Hello and welcome to another NetQuiet video. I'm your host Travis, and today I'll be doing another video on configuration of the Single Palo Alto VM in Azure. If you're watching this video, then in the last video we deployed a Single Palo Alto VM in Azure. We did some initial configuration, and today we're going to be adding a Linux VM into the Trust subnet in Azure. We'll also be configuring the Palo Alto to allow traffic flows to the host from the internet. Keep in mind this is the second video in this series, so if you're at this point and you haven't seen the first video, check our channel for that first video. With that being said, let's hop. Okay, so just to get ourselves oriented here, this is our Palo Alto VM that we created in the last video. Now, if we look at the network, we do have two zones set up, a trust and an untrust zone. We have two interfaces that are configured, 1 and 2. We have two virtual routers, an untrust virtual router and a trust virtual router. And for policies, we have a policy to allow from the trust zone to the untrust zone on any application, any service. And we do have a NAT policy in place to translate the source packet for traffic going out to the internet. So what we'll be doing today is adding a Linux VM and adding the configuration that's needed here in the Palo Alto for us to be able to reach the VM and also for the VM to be able to go out to the internet or in further cases to be able to reach other zones. So we'll look at all those use cases here. So let's start by going over to Azure and adding that VM so we have that available. Okay, so the reason we've come over to Azure is based off of our current setup, our Palo Alto is able to ping from the trust interface out to the internet. But what that doesn't allow us to do is to ping from devices within our trust subnet, because currently the gateway for the trust subnet is Azure and not our Palo Alto. So what we're going to do is we're going to go into our Palo Alto virtual machine and let's look at the networking here. If we look at our ETH2, which is our trust subnet, what we don't have in place is a route table. So we're going to go ahead and create a route table. And what this route table is going to do is point all of the traffic that exists within the trust subnet and point it, instead of to the gateway, we are going to point it to the Palo Alto. So let's go ahead and create a route table first. It's going to validate that that's fine, and we'll go ahead and create, and it will deploy the route table. Once this route table is ready, what we're going to do is go to routes, add, and I'm just going to call this the trust. Doesn't really matter. And the prefix here is what address destination. So in this case, I'm going to say the default route. And instead of using the gateway, I want to point to a virtual appliance. And they want the IP address of that virtual appliance, which is 10.0.2.4, which is Ethernet 1.2 on the Palo Alto. We'll hit OK. And then what we'll do is we'll go back to our virtual machines. We'll select our Palo Alto, select networking. We'll go over to ETH2. We'll select the trust subnet. We'll go down to subnets. And you'll see here there is no route table selected. So we'll select trust, route table, trust, and save. So now when we add devices to the trust subnet, they'll know that the traffic, or Azure will know that the traffic is bound for the Palo Alto. Now with that being said, let's go and create our Linux VM. We'll go over to virtual machines. We will create a new virtual machine. We'll use the same Palo Alto resource group, and I'll just call this Linux. Standard security, the image here, it's totally up to your personal preference. I'll just use the recommended Ubuntu server. This is going to be the standard sizing, and I will go ahead and put in a username and a super secret password. Now, we do not want any public inbound ports because we are not going to be using a public IP address on this. This is going to live solely in our trust subnet. We want this to have just the standard premium disk, and then we'll go to networking. So it's going to ask us here, what do you want your public IP to be? And what we're actually going to say is none. And we want this to live in our trust zone. So what's going to happen here is it'll live in the trust zone. It'll get a 10.0.20/24 address, probably 10.0.25. And it will be accessible only from the trust zone at that point. And what we're going to do is we're going to NAT the traffic coming into the Palo Alto with a destination of this Linux machine. And that's what we're going to work on here in just a moment. So we'll scoot forward to management. Nothing to really change here. Advanced, nothing really to change here at this point. Tags, feel free to add a tag if you'd like. But let's go ahead and just have it validate. Make sure everything's good to go. It's past its validation. Let this get this VM created. And once this VM is created, we're going to go over to the VM and we're going to check which address it got in the trust subnet. So let's do that now. All right, so we are back over at the virtual machines. Let's go into the Linux virtual machine here. And as we expected, we are getting a 10.0.25 address for this particular VM. That's what we expected here. So let's go over to the Palo Alto and start working on the NAT and security policies to be able to access this VM from the internet. So you'll see here I'm in policies, NAT, and I'm going to go ahead and add a new policy. And I'll just say SSH to Linux. And the original packet, so if we think about the flow, we are coming from the untrust or internet, and this will be destined for the untrust interface on the Palo Alto, which has the public IP address, so untrust as well. For service, I've created an SSH service here, so looking for things coming in on port 22, and a destination address of the untrust interface, which would be 10.0.14. Again, remember it has a public IP, but in terms of this device, it thinks it's at 10.0.14 because that is what Azure is telling it. For the translated packet, this time we're not doing the source, we're doing the destination. So we are going to do a dynamic IP, and the translated address will be the Linux address, okay? So create a new address for Linux, which will be 10.0.25. And for the port, 22, okay? And then we'll hit OK. It'll add that to the list. And we will create a security policy as well here. So adding a new policy, we'll just call this SSH to Linux. And again, your corporate policy might be different than ours or anyone else's, so make sure you keep track of how that should be named. So this is going to have a source of untrust, a destination of trust, application we'll leave as any here, and service we are going to say SSH just to match our NAT here. For action, we are going to allow it. I'm going to log at start and end just so we can see those in the logs if need be, and I'll hit OK. And then from there, all that's left to do, always, always, always make sure you commit your changes. And once these are committed, we'll go ahead and open up a PuTTY session and we'll attempt to connect to this Linux box. So let's do that now. And I actually want to stop at this point because this brings up a good point. For new network engineers that are out there, or for those of you who have not really worked with the cloud very much or Palo Altos, your first inclination might be to look at your URL bar on your browser and take that and punch that into PuTTY. We need to remember here that the IP that's listed for the Palo Alto, that's going to be the management IP of this device. If you remember, we go over to device, and we go to interfaces, and we have our management interface, which is the ETH0. We actually want ETH1, which is going to be our untrust interface. And just to remember what that was, let's go to Palo Alto. We are going to select the networking component here, and we're going to go to ETH1. And this is actually the public IP address that we want to connect to. So let's get that punched in here. And let's open this connection. And you'll see that we've got a shell going here. Just to verify that we are actually logging into the Linux box, let's get logged in. And you'll see here, Travis at Linux. This is our Linux machine that we just created not that long ago. And just for sanity's sake, let's make sure that we can ping out to the internet. And we are indeed able to ping out to the internet. So we could run some sort of service on this, and like we were really hoping for, have the Palo Alto protect this virtual machine. So what do we have at this point? We have a Palo Alto, a single Palo Alto in the cloud that is protecting our workloads in the trust space or trust subnet. We have a Linux machine that is living in that trust subnet, and that machine is able to get out. We're able to reach the machine virtually through PuTTY, through the security of our Palo Alto. And we could set up multiple different devices and then just change the ports per device, so that way we could connect through one public IP towards multiple different Linux instances, or if we have some Windows servers. What we could also do is, if we decide that we want to segregate some of these devices, what we could do is we could add another interface to our Palo Alto. Now, we would follow the same path here. Let's say we want to add a DMZ zone. If we add another interface, and we would let it get its own IP space, likely in this case it would be a 10.030/24, and we could call that our DMZ subnet. We would go over to the Palo Alto, we would go to networking, go to interfaces, select 1.3, and do follow the same steps as we did in the first video, and we would want to go ahead and add a virtual router. And in this case, the virtual router would be, let's call it the DMZ virtual router, with the routes pointing towards a default route pointing towards the virtual router of the untrust virtual router, and then a specific virtual router for 10.0.20 pointed towards the trust virtual router. And we would also need to update our untrust virtual router to have a route to the DMZ, and the trust virtual router to have a route to the DMZ. So that would allow us to have traffic between all of the different zones. And then, as needed, let's say we add another Linux machine to the DMZ. We would need policies at that point that allows traffic between our trust zone and our DMZ zone, or vice versa. So the big thing here is just, what is your use case? And I would recommend spending some time getting used to the Palo Alto, as well as the features that are available on the Palo Alto, because there is a wide amount of things that the Palo Alto can do, not just looking at ports or IPs. We can look at user ID and actually narrow it down to specific users if you're tied back to LDAP or Active Directory. You could look at specific applications. So let's say I want to look at SSH, the application, not port 22, the service. So you can really narrow it down as to what is being allowed, and you do want to have the least amount of openings in your firewall as possible. You want to make sure everything is locked down as tight as possible to keep your security up. So with that being said, that's just a light introduction to what can be done with Palo Alto in Azure. I will be looking at some future videos to look at some of the more advanced components here, potentially some user ID, looking at creating policies with application ID versus service, creating some profiles and profile groups, just so we can view what those are. I do hope that this video has been helpful. I know that it is a little difficult finding resources for Palo Alto in Azure, specifically a single Palo Alto VM in Azure. So I do want to thank you for your time. So if you head over to NetQuiet or to our channel here on YouTube, you will see some additional videos on both Palo Alto and FortiGate at the moment. We are working on adding more resources as time goes on. If you have any questions, feel free to reach out to me directly, tbrown@netquiet.com, or drop over to our site and use our contact form. And while you're here on YouTube, make sure you smash that like button and follow us for any future videos. I do appreciate your time today and hope you have a wonderful rest of your day. Thanks so much, everybody. Bye.